Yeah.
so we can enjoy the rest of our weekend.
That's a messed up job. Why they doing you like that?
No, it's me because I don't know.
What for this weekend? But I need to be.
Cool, so now, understanding Newton's third law of motion and applying Newton's third law to define systems and solve problems of motion. All right, so this is pretty crazy. Baseball relief pitcher Mariano Rivera was so highly regarded that during his retirement year, opposing teams conducted farewell presentations when he played at their stadiums. The Minnesota Twins offered a unique gift, a chair made of broken bats. Any pitch can break a bat, but with Rivera's signature pitch, known as a cutter, the ball and the bat frequently came together at a point that shattered the hardwood. Typically, we think of a baseball or softball hitter exerting a force on the incoming ball, and baseball analysts focus on the resulting exit velocity as a key statistic. But the force of the ball can do its own damage. This is exactly what happens whenever one body exerts a force on another. The first also experiences a force, equal in magnitude and opposite in direction. Numerous common experiences, such as stubbing a toe or pushing off the floor during a jump, confirm this. It is precisely stated in Newton's third law of motion. Whenever one body exerts a force on the second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that it exerts. So if I could get some of this back and then just kind of put our 1, 2, and 3. So we can kind of see it a little bit easier. So Newton's first law has to do with inertia. Object at rest / motion. Right? Newton's second law and Newton's third law. Newton's second law is just saying that the net of forces equal acceleration, which is also inversely proportional to its mass. Then Newton's third law is that any rest or any object gives an opposite and equal reaction minus. I think that's the way I can put it. F net equals negative F net. So I'll say F net of the first system equals negative F net of 2. Something like that. Whenever one body exerts a force on the second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that it exerts. So that's a good way to look at that. This law represents a certain symmetry in nature. Forces always occur in pairs, and one body cannot exert a force or another without experiencing a force itself. We sometimes refer to this law loosely as action and reaction. Alright, so then Consider a swimmer pushing off from the side of a pool. She pushes against the pool wall with her feet and accelerates in the direction opposite to that of her push. The wall has exerted an equal and opposite force back on the swimmer. You might think that two equal and opposite forces would cancel, but they do not because they act on different systems. In this case, there are two systems that we could investigate: the swimmer and the wall. So we'll see how the swimmer, you got the force of the wall on her feet, but then on the wall you also got the force of the feet on the wall. So and then we want the swimmer, usually the person, the free body diagram. So that force of the wall on the feet is that force. And then we have the gravitational force. Well, BF is the buoyant force of the water supporting the swimmer's weight. The vertical forces, W, weight, and BF, buoyant force, cancels since there is no vertical motion. All right. Say that again. Oh yeah, you could calculate the force of that, but that's why she's got her head down.
Still going.
You gotta breathe out your nose.
Yeah, when you come up. Anyway.
Really?
So other examples of Newton's third law are easy to find. As a professor walks in front of a whiteboard, she or he exerts a force backward on the floor. The floor exerts a reaction force forward on the professor that causes him or her to accelerate forward. Similarly, a car accelerates because the ground pushes forward on the drive wheels in reaction to the drive wheels pushing backward on the ground. So we're talking a lot about that in the normal force. In another example, rockets move forward by expelling gas backward at high velocity. You know, cars tend to push the gravel road and throw rocks behind, you know. So with the rocket aspect, looking at thrust, this means that the rockets exert a large backward force on the gas in the rocket combustion chamber, and the gas therefore exerts a large reaction force forward on the rocket. This reaction force is called thrust. So it's a common misconception that rockets propel themselves by pushing on the ground or on the air behind them. They actually work better in a vacuum where they can more readily expel the exhaust gases. Helicopters similarly create lift by pushing air down, thereby experiencing an upward reaction force. And then also drones. Drones do that too, you know, drone copters. So they actually have a